Good morning. And this chapter is talk about the short time scheduling. And we already explained one example. So this example is saying we have A, B, C, three printers. They all can do the job. They are all able to do the job R34, S66, and T50. But with different machines to do different jobs, they will end up with different cost. The scheduling problem of this one is to try to find out the optimal schedule. Then we end up with the minimum cost. What we did is over here, I only explained what is the procedure to assign the different jobs to different machines. We didn't tell you why we use this assignment method can help us to get the minimum cost. That will beyond our kind of like class. That involves a lot of math. Our tasks is to just use the method to assign different jobs to get the minimum cost. And in this example, we explained over here is, okay, the first step is to look at each row and to subtract the minimum number for each row. For example, the first row is 11, 14, and 6. And if we subtract 6, and because 6 it is the minimum number over here, and this row is subtract 6, we get it is 5, 8, and 0. For the second row, we subtract 8. That's the minimum number. And then the third row, it is 9. It is the minimum number. Now we end up with this new matrix. Okay, and the second step is to subtract the minimum number of each column, in each column. So for A, because you already have 0, if you subtract 0, and this column will stay same. But for column B, we see, okay, 2, it is the minimum number. If we subtract the 2, now you have is 6, 0, and 3. And the third column, we already have 0. That's why it will stay the same, because every number you subtract 0 is the same. And the next step is to try to cross all the zeros and use a line. You see how many lines you have. Now we have 2 lines, we can cover all the zeros. If the number of lines is less than the number of columns, the number of rows, that means the solution, it is not optimal. You have to keep working to subtract these numbers. So the next one, it is, okay, smallest uncovered number from the matrix, it is 2. Okay, and 2 over here, so the smallest one, if we subtract 2 from this column, now it is 3, 0, and 0. And then this one will be 6 subtract 2, now it is 4. So 0, you will not change, but 3 subtract 2, it is 1. Okay, and after this step, we can see we still want to use the lines, vertical and horizontal lines, to cover all the zeros. So now we see, okay, we can have 3 lines. The number of lines are equal to the number of columns. That means the solution, it is minimum. So solution is minimum because we have 3 lines, 1, 2, and 3. You have rows, it is 1, 2, 3, and the columns is 1, 2, 3. And when it is minimum, and you look at over here, is all the zeros. So the zeros, and here, this is the zeros. These are the these are the best kind of like assignment. So row 1, you only see 1 0. That means you have no other choice. So R34, you have to assign this to C. So, and R34 in this row, we only have 1 0. Okay. And then look at, for job T F50, for this one, you can have the choice of assign this one to A or assign it to C. But because we already assigned R34 to C, now for T50, you only have the choice of A. And then we already, match T50 with A, match R34 with C. So, and look at this last kind of like row we have is S66. You can have choice A or choice B. Because we already assigned the T50 to A, only this choice can be used. B will be working on job S66. That's the kind of like the 3 solutions we see. So if you see the next slide is we are going to pick, okay, R and 34 to C. So it's going to be $6 over here. And then pick S66 to B. So this is B, this is $10. And the last job, T50, you are going to assign this to A, which matches up the cost, it is 9. So the total cost for finishing all of the 3 jobs and by using the 3 printing machines is total 25. You can work with different combinations in this, a different assignment, but this one, it is the minimum, so 25. And this is the example. The goal is to minimize the cost or minimize, you have this schedule. And the second example, I'm going to, this is kind of like a review of a previous class. And the second example is sequencing jobs. If you have several jobs to come, and how are you going to schedule them? And then there are different priority rules. You have first come, first serve, or shortest processing time, or earliest due time, or the rule to sign or sequencing these jobs, longest processing time. So all these rules, we are going to use an example to use Excel. This one you have to use Excel, okay? And if you want to use manual method, it's okay. But if you have, I think Excel is a good way to help you to quickly solve the problem. And the judgment performance criteria we can use is minimizes the completion time. Or you can say it is maximizes the fertilization or facility utilization rate. You want to see less idle time. And try to make all the machine busy, make all the workers or technicians busy. And you don't want to waste their time. The third one is minimize the number of jobs in the system. And what that means, minimize the number of jobs in the system. Because when you're only one job can be processed at one time. And if there are so many kind of like jobs are all pushed in this system, that means, and a lot of other kind of like only one is being processed, the rest is kind of like a waiting. Waiting is the waste of time as well. So you want to reduce the waiting time. That's why minimize the number of jobs in the system. Another judgment performance criteria, it is minimize the job lateness. We want to compare the completion time with the required due time to see what is the lateness. Okay, and then in this example, we are going to bring one more concept over here. It is the flow time. Flow time, it is the time being released, is the release of the job to the work center, and until the job it is finished. So this flow time must include all of the kind of like waiting time. So, and using Excel, you see flow time can be easily calculated as a cumulative processing time. So, and then, and these are the performance criteria. So we use the mathematical formula to to express the kind of like what we just talked in the previous slide. Okay, how to calculate a completion time, how to calculate a facility utilization rate, and the number of jobs in the system, and the lateness. So here it is the formulas we are going to use in this example, and to see, and we compare all of the 4 different sequencing method. So we have first come, first serve, and the early due time, and the shortest processing time, and the longest processing time. So we use all of the 4 sequencing rules, but for all of the sequencing rules, we will calculate what is the average completion time, what is the utilization rate, and what is the average number of jobs in the system. And also we will calculate the job lateness. I want to go through this formula because the formula will make you kind of like feel, oh, what are they? So we better use our example to see, what is the lateness, due time lateness. Here we have A, B, C, D, E kind of like jobs. These 5 jobs, and the job work processing time in days. So A, you need to complete this. You need to work like 6 days to finish A. So 2 days to finish B, and C, D, E is here. But also, when these jobs are listed over here, we are given the due time. So, and A will be due in 8 days later. B will be due in 6 days later. So, and the C, D, E will be due in 18, 15, 20, 23 days later. So we will work at the sequence, first come and first serve. So we just use A, B, C, D, assume A comes first, B is second, C, D, E. So that's their coming sequence. Of course, we are going to work on them, first to work on A. So, and if this is day 0, so day 0, we start to work on A. B is waiting, C, D, E. They will be processed according to their sequence. So, in the flow time, it is cumulative of the processing time. So here, because that's the first one, and nothing to accumulate, but just only itself. So this flow time equals to and job processing time, and compare with the due time. Now it is nothing late. So your job lateness, it is 0. But for B is coming here, processing time is 2. Remember, we only have 1 machine it is working, or 1 people is working. And then, so we have to wait for this to finish, and then start the B. So this flow time equals to, and the previous flow time plus the working time. Why? It is because 6 is waiting time. Okay, flow time, it is the job released to the work center, and plus until it is finished. So we come over here and wait for A to to be processed and then finished to start to B. And then now, after you finish B is 8 days. But compared with the due time, it is late 2 days. So basically, that's the two difference. So 8 minus 6 or 6 minus 8, you use the absolute value. And for C, job working time, and then flow time equals to 8 plus 8. Now it is 16. And the job lateness, yeah. So compare with 16 and 18. Now it is no late. So lateness is 0. For D, and waiting time, it is 3 days. So it is 19. Finish time, it is by the time finish job D is going to be 19. So compare with the late due the job due time. Now lateness, it is 4. So E is work processing time, it is 9, and we have 9 plus the 19, it is 28. Remember in the last one, so this one, it is the total of all the flow time. So basically, and this column, it is calculated the sum, but we do not calculate this one, only calculate late job lateness sum. And so go to your Excel work. And go to the Excel work. Actually, I have already put the formula. I only delete my result over here. And average completion time equals to the flow time, total flow, sum of the flow time divided by 5. And utilization rate equals to sum of job work time, processing time divided by the sum of flow time. And the next one is average number of jobs in the system. And this one, it is, and use 77 and divided by 28. And here is the average, the result is 2.75. And this means, okay, from the whole working process, on average, there will be almost 3 jobs in the system. That means, okay, 1 job is being processed at least, and about 2 other jobs are waiting. That's 3 jobs in the system. And the lateness is 2.6. That is 13 and divided by 5. And the second rule, so the second rule we put over here, it is SPT. S means shortest, P processing, T is time. If you look at this, shortest is the process time should be B, D, A, and C, and E. So it is B, D, A, C, E. And then we need to reorganize this as well. Question?
So on the first come, first served section,
Mm-hmm.
for the job lateness,
Mm-hmm.
there's 13 for the total, but on the PowerPoint, it said 11.
Oh, PowerPoint said is 11 is because here it is wrong. So this one, it is job is no late. Yes. Okay. So I don't know. So I didn't use a formula. Okay, I should always use a if function. I didn't use the if function, and it's a good way to put it is the late function equals to if this number subtract this number larger than 0, and then it is late. D10 minus C10. Otherwise, it's 0. I think this one will be better. So I can drag this formula, come down. Should be flow time C10 minus D10. And here is C minus D. Okay, here is better. So originally I didn't have any formula. I just calculate, and probably I made one mistake, and then the total number is wrong. But if you put like compare the flow time with job due time, if the flow time, the finish time, it is larger than the due time, that means you have lateness, and then the lateness will be C10 minus D10, will be flow time subtract due time, and otherwise it will be 0. This one, it is correct. So for the second rule, do you know how to work this as a kind of like sort data? So home, let's see. Sort. If I sort this and then sort this values by work time and from small to large, and they will provide you BDACE. That's your BDACE. So, and otherwise we can, originally this is sorted by alphabet order. So we can use data to sort it back is and job, and then here that's the given kind of like a sequence. So if you have several more than 5 jobs, the easier way to do it is do the job by sorting function. So now we calculate what is the flow time. The first one, flow time equals to itself. The second one starts with diagonal sum. And then we add them all. And we want to add the sum function of A, B, C, D, E. And also here, this one, it is flow time. And the job lateness. So I will sort this to, in case I make mistake. So here it is sort and work time from the value from small to largest. So the flow time, the due time should be 6, 15, 8, 18, and 23. So we can use the previous function. If flow time, it is larger than the due time. Larger than due time, that, and then it is I sub I10 subtract J10. Otherwise, it's 0. So for 5 and 15, there's no lateness, so it's 0. For C, it's 11 and 8. 11 larger than 8, 3 days lateness. 19 is larger than 18, 1 day. So we can calculate the sum. job lateness. Similarly, we use all the functions. Okay, completion time. This one, it is flow time divided by 5. So 13 days. Utilization rate, 28 divided by 65. Compare with the previous sequencing rule. This one increased a lot. That means there is a kind of the utilization rate, it is getting better. And the job, average number of jobs in the system, we reduced a little bit, and the lateness improved. So that's the third that's the second sequence rule. Short is the processing time. And the next one, it is early due time. I think it is early due time. I don't know what's the D that means. EDD. Early due date. Earliest due date. Okay. So according to this, I'm going to reorganize this original data. So let's use the sort function and put your job due time and from small to largest. So will give us a different order. This is B, A, D, C, E. So it's B, A, D, C, E. Now the process time, and so here I can copy to this. So here we can change the color. I want to check with here is 6, 8, 15, 18, and 23. Copy this to the job lateness column. Okay. Flow time equals to 2. And the next one is 2 plus 6. Diagonal. And copy, I copied this back. It is here, it is due time. And the lateness, we will compare the two columns, flow time and job due time. So I'm still using this if function. If flow time, it is minus, and the lateness, the due time larger than 0, then equals to O10 minus P10. Otherwise, it's 0. So second job over here, flow time and due time, they are same. So there's no job lateness. So for D, no job lateness. And then we can calculate the sum of, so equals to sum of work time, sum of flow time, and sum of lateness. So my formula already there. We can, the Excel file provide you the answer right away. It's 13.6, utilization rate of 41.2, and average number, so equals to 68 divided by 28. Lateness and there are total 5 jobs. The average lead time it is 1.2 days. So the last rule, it is a longest processing time. Which one is the longest processing time? We will work on this specific job first. So now I'm going to go back to my original kind of like A, B, C, D, E job, work time, and due time. I'm going to organize this data and sort by job work time, but it's from the highest to the lowest. So if you use this, now it is E, C, A, D, B. So compared with here, E, C, A, D, B. And then we need to copy these 2 columns of the data to the new table. So it's job over here. Okay, and here is not a flow time, 23, 18, 8, 15, and 6. These are the job due time. So due time here. Flow time, you can insert all the numbers by yourself. Diagonal sum. And we can have the sum function for job work time, flow time, and lateness. So lateness equals to if function of subtract and the due time. If this one larger than 0, equals to this minus here. Otherwise, it's 0. So here, we can fill out this column, so sum. Wow. Now I'm going to zoom it out. That is, see, we finished all the 4 different rules, but I want you to put these numbers into this kind of like a calculation result. For FCFS, first come, first serve, and the average completion time is 15.4. And the next one, utilization rate, 36.63. 36%. And the average number of jobs in the system, 2.75. And the next one, lateness, 2.75. And the lateness is 2.2. Second rule, match with your color. It is 13 and 43.1. And 2.32 average number of jobs. And the next one, it is 1.8. For the blue color, 13.6, 41.2, and the next one is 2.43, 1.2. 20.6. 27.2%. The next one is 3.68. And the last number we punch in is 9.6. Okay, so now we finish all of the 4 different sequencing rules. I'm going to zoom in to see this comparison regarding all of the performance criteria. So we have the average completion time and utilization rate and the average number of jobs in the system. So lateness, we know completion time, the smaller the better. Utilization, it is, and the larger the better. So this one is smaller the better. And the lateness is smaller the better. So according to this, the utilization and average completion time, so 13, it is the good number. Okay, it is the lowest one. Shortest the processing time will give you the best result. According to utilization rate, so 43.10. So again, and it is the shortest the processing time will give you the best result, because this one will be the larger the better. The average number of jobs in the system and is going to be the smaller the better. So, and 2.32, that's one. It is it is very close to, well, it's closer to 2.43, but it is, and the SPT is still the smallest number. So overall, and average lateness 1.2. This one, it is the better result. And here in our slides, I'm showing this as well. So comparison of the sequencing rules. SPT, shortest the processing time, does well on minimize the flow time and also minimize the number of jobs in the system. And but the shortest processing times moves long jobs to the end, which may, cause customer not happy. And because the customer, they do not really care about your utilization rate, whatever, the efficiency of your operation. They care most of the time whether it's fair. So it is first come and first come first service is the fairest rule according to mentality of general consumers. And this one does not always do will be used as the criteria. For example, the hospital operation rooms or the hospital emergency rooms. Emergency rooms cannot use first come, first service. They always see who is the emergency. Okay, compare all of the patients. So EDD, it is minimums the maximum lateness. That is the shortest the due date. Here is the simple Excel work. And I think it's very easy to understand what is what do we mean by flow time, and what do we mean by job lateness calculations. I think word you pointed out a mistake. I correct right away. I'm using a formula right now. The formula will be a generic formula you can apply when you need to work on the job lateness as well, right? So this one will be better. It's tedious, and but it's not hard at all. So for this sequencing rules. And another kind of methods to look at the job sequencing is given a priority. So here there's a definition. We can define a critical ratio. So this is the ratio. Actually, it is the index number. You can use the remaining time. So the work remaining time and the time to process it compared with the due time. So look at what is the time right now and how many days will be due. So this is the time remaining to finish the job according to the due time. But also you will divide or compare with the how many work days remaining to process. So in this formula, we use the due time and subtract today's date, and then what is the work or lead time remaining, we get the ratio. And this ratio, if it's larger than 1, that means your job is ahead of schedule. So if this critical ratio it is smaller than 1, that means your current status is late compared with the schedule. So if it's late, you want to put in the highest priority. For example, and we have ABC jobs, also give the due time, and but today it is 25th, day 25. Okay, and for job A, there are 4 kind of like work days remaining, and use the due time, subtract today's date, and divide by work days remaining. Now you get that is 1.25. 1.25 larger than 0. So, and this A is C it is equals to 1. It is right on schedule, and B it is late. So B is late. You want to B is late. They have the highest priority. I think A is having some kind of like a slack time. So that's the critical ratio technique. And we use this technique, ratio, to determine what is the status of the specific job according to the planned due time. And then can help us to see which one I will, catch up. I need to catch up. I need to put as the highest, higher priority. And the adjustment priorities automatically for changes in both demand and job progress. And so critical ratios is a simple ratio. They only give you the status of the job and give you priorities, but they didn't tell you, and the specific numbers of what is the flow time and so on and so forth. This one, I think it is a very important rule, Johnson's rule. And if you look at the textbook, I'm not sure you can read or comprehend 100% or not. Hopefully, yes. But I want to give you, explain how Johnson's rules, so we can sequencing like N jobs, A, B, C, D, E jobs on 2 machines. The 2 machines, you can call them machine 1 or machine 2 or machine like alpha and machine beta. So this kind of like we have rules. We have like A, B, C, D, all of these jobs, and all A, B, C, D. These jobs, there is assumption of using these rules is, and they have to go through machine A first, machine 1 first, machine 2 second. The sequence is always this. So for example, A needs to be processed, job A needs to be processed in machine 1 first. and then moved to machine machine 2. And this is the example is showing, okay, how about we first to do the machining process, it is, and do the first one, it is the median operation. We only want to create a flat surface. Okay? This one must go first. And then the next machine, it is grinding. Grinding is to try to get a finish like a surface. And we consider this, it is median, it is what? It is a rough operation, and grinding, it is a finish operation. So this sequence of the machine 1 and machine 2, they cannot go opposite with each other. And this rule, the Johnson's rule, is to minimize the total production time and the idle time. And n number of jobs, for example, 5 number of jobs, A, B, C, D, E representing the jobs. And then we have 2 machines. So Johnson's rule, if you read over here, you first is list all the jobs and the times for each work center. Let's see the example. Here is list. We list all of the jobs. We list all of the work times for the machine centers, 2 machine centers. That's the first step. And then select the job with the shortest activity time. First, try to find out from the timetable, look at which one is the smallest number. So if the smallest number, the shortest time, it is with the first work center, schedule this job first. If it is the second work center, schedule this job last. Okay, what do we mean over here? We look at this table. So look at overall, what is the smallest number? 2, correct? 2 is the smallest number. It said, if this number, the smallest activity number, it is associated with machine 1, you need to put first. Otherwise, if it's with like a work center 2, you need to put a second. So assign this A with put in the last one. Okay. And then look at the next smallest number. Next smallest number, it is 3. Now it is with work center 1. And then we need to assign this work or job in the first sequence. Go and look at the next one, should be this one, 4. 2, 3, 4. So 2, 3, 4. Because it is associated with machine 2, we put over here. And then we strike out this machine, job sequence C. Compare with the rest DE. DE you have 7 and 7, and anyway, and that's the kind of it is here. If you pick this number, it's going to be and E, and the last one, it is 10, it is D. So if you read over here in the previous slide, select a job with the shortest activity time. If that time is in the first work center, schedule the job first. If it is in the second work center, schedule the job last. Break ties, randomly. Once a job is scheduled, it is eliminated from the list. So we need to repeat this 2 and 3 several times. Here is the example. Now here it is the sequence, and here it is the sequence. But we always remember the machine 1 will go first. machine center will, work center 1 will go second. So drilling process is first, and lathe operation will go second. And we see for the first machine, work center 1, and you can, finish the job one by one, B, E, D, C, A. So we just list this. We just list this, and look at the processing time for B. And we need 3 units to finish B. After that, and it is E. E is going to take 7. So once B finished is at 3, you plus 7 now equals to 10. Right? And for D for work processor, it is work center 1, you need to take 10 like a working unit. So this one plus 10 equals to 20. And C, it is 8. So C, it is plus 8. Now, after finish D, it is at 20. 20 plus 8 equals to 28. And 8 is the last one. So, and plus 5. And for work center 1, you finish all of the jobs, B, E, D, C, A. Now, the final kind of completion time is 33. However, for work center 2, you cannot put this one by one connected to each other. You have to look at what is the due time, okay, for the previous step. Let's look at because we said after you finish the drilling process, you can move to the lathe process. And B, at work center 2, you cannot start until this first work center finished. So the starting point will not be 0. The starting point will be 3. Here is 3. So here is B. B is 3. And B is going to take 6 units, time units. So 3 plus 6 equals to 9. So finish B at 9. And then let's look at the schedule, like a sequence. After B should be E. But I cannot start E at this line, at 9, because E has not been finished at work center 1 yet. You have to wait 1 time unit. So wait, E finished is done at work center 1. So start at 10, 10 plus, and here it is E, it is 12, so plus 12. Now it's 10 plus 12 equals 22. Okay, here, finish E over here. Now we look at, did we finish D in the work center 1? Yes, you already finished. Now the next one, it is D. So we can add D over here. D, it is 7, so plus 7. 22 plus 7 should be 29. And after D, it is C. So C is 4. C is 4. And 29 plus 4 equals to 33. A. And A, can we start the A right away? Yes, because A also finished the job at work center 1 right at 33. So 33 plus 2. This one, it is 35. So And using Johnson's rule, you can assign the multiple number of jobs to two machining or two rooms or two like technicians. And the rule, kind of like a sequencing rule, is to see which one is going to be the smallest number associated with work center 1 or work center 2. So if the smallest number is associated with the work center 2, you need to put the last. If it is associated with the work center 1, put it first. And also there's the logical sequence is all the jobs must go through the work, like a machining sequence is the first machining 1 and then machining 2. Or you can say is first is a technician 1 and then it is a technician 2. And this example showing us, okay, for work center 2, you cannot start from the 0 point. You have to wait for job B and finished at the previous machine and then start. And then we see, okay, every time you finish this job, you have to see, okay, what's my next job? My next job is E. And then I'm going to compare whether E has been finished yet in the previous workstation. So, and then we can organize this one. And this schedule can let you find out, okay, what is the due time overall. In this example, it's 35, it is the due time. And also can help you to lay out the sequence. By the way, I don't know whether, because I have the practice in Excel, and then, you know, I put the numbers above over here. That's exactly what you see in the PowerPoint slides. And I hope you understand. And if you do not have my result over there, you can delete them and try on your own. Can see if you can come up with the same kind of like a Johnson sequence, Johnson's row sequence, and also to see if you can get this kind of like a result correctly.
We don't have that one.
Oh, so I didn't give you this solution, did I? Let me see.
The only thing we have is the work center and workstation.
Okay, let me see.
That version.
Okay, this one. Sequence, yeah. I didn't give you that. Yeah, the reason is I want you to practice on your own to see, you know, similarly, this is the same example from the textbook. Because I'm using PowerPoint, they, you know, here give you a clear view already. If you do it on your own, you know, you scratch on the paper, you should be able to accomplish this result. That's why I emphasize this. I do have this type of question in the final exam. So you need to cover the result. And then try on your own to see if you can use the Johnson rule correctly. If you can generate the result, finish time correctly. So in the exam, I'm going to give you this job list. First, I want you to give me what is the job sequence. Okay, you need to figure it out. And the second one is maybe I also ask you what is the completion time. So we practice over here, or I explained over here to you. And the limitations of rule-based dispatching system, you know, rule is always fix the rule. Rule means They are not a person. They are not flexible. You talk to the rules. If there is a computer system, if you define the system already, they always give you the rule according to, okay, the sequence according to the rule. That means, it's kind of like less flexibility. And the rules do not look at upstream or downstream, and do not look at beyond the date. So, and if there's kind of like a dynamic situation, and then the computer probably, you need to look at the computer as your reference and also consider some kind of like flexibilities on your own of making the decisions. But the rules at least give you a very good reference point. You understand, if I'm using these rules, what is my status of the job? Okay, am I late? Am I ahead of time? Or, if I'm using these rules, what is the utilization rate? What is the idle time? So can help you at least give you the reference or baseline to see, okay, how good you are. And then for manufacturing and service, they have some kind of like a difference. Manufacturing people, and they mainly try to schedule material and the machines, but for service, quite a few times they look at staffing. So how to put people into different like work schedule. And manufacturing, they can carry some inventory to smooth the working process, but service people or service, they very seldom and keep inventory. Keep inventory for them means they hire extra people. Who will do that? Nobody, right? And legal issues associated with kind of like scheduling as well. How many maximum hours employee can work physically, or some kind of like limitations we need to consider. And so these are the difference between scheduling in manufacturing and service. Hospitals are example of service, banks, and retail stores. Hospitals and have a very complex scheduling system. Well, is somebody on call 24 hours a day. So even though they are off at home, but if they receive a phone call, they need to go to the hospital immediately. It's because their specialness of the job. And retail stores, like Walmart and Target, they have their computer system help them to do the scheduling. And airlines and 24/7 operations, police, fire department, emergency hotlines, so on and so forth. You can take a look at the book. But I think airlines, their job, short time schedule is especially important for these type of organizations. And the last example in my PowerPoint or in the kind of like Excel example, it is cyclical schedule. Objective, it is to meet the staffing requirements with the minimum number of employees. So the schedule needs to be smooth and keep everybody happy. Keep everybody happy means you don't want to overwhelm or overload these employees. Give them legal rest of the time. Everybody work 20 or 40 hours a day, 8 hours, 40 hours kind of like a day. And then that means each week they have 2 days rest. So look at this example. And the staff requirement for a clinic, it is Monday, Tuesday, and Wednesday, Thursday, Friday, Saturday, and Sunday. This clinic, I guess, is a walk-in clinic because they open Saturday and Sunday as well. And for employee 1 and everyone, for each of the one, they found out the shortest, smallest number. They will, find out the smallest requirement. That means you can put this, and employee 1 rest Saturday and Sunday. And then the next one, it is, okay, we minus 1 from the previous row. So 4, 4, 5, 4, 3. But the 3, 3 you will keep. You don't want to minus. Now you have, and then find out what is the smallest number in this row, 2 smallest number. So, okay, 3 and 3. You can also put this 3 and 3. This is the decision, of you. So that means you are going to give this person, employee 2, rest at Saturday and Sunday. Keep doing the same. Keep 3, 3 not changed, but the rest of the numbers subtract 1, subtract. Now we have 2 and 3. These 2 numbers, smallest. So that means, and employee 3 will get rest Friday and Saturday, but it's going to work on Sunday. And repeat this, and now until you find out, okay. And so these 4 is going to rest Tuesday, Thursday, and Friday, and 5 is going to rest Monday and Tuesday. 6 is going to rest Saturday and Sunday. Now you will see, and all of for Monday they have 1, 2, 3, 4, 5 employees, right? They need how many? 5. And then look at this Tuesday, they need 5. 1, 2, 3, 4, 5. And Wednesday, peak value. So it's 1, 2, 3, 4, 5, 6. 6 meet the staff requirement. So 1, 2, 3, 4, 5. And for Thursday, for Friday, you see 1, 2, 3, 4. And Saturday is 1, 2, 3. And Sunday, 1, 2, 3. So basically, these is help to meet the staffing requirement. Here is pointing to 5. This is pointing to 5. Here it is 6. And overall, we see in this schedule, well, you have 6 employees. You can finish the work, but 7 probably is just a little bit extra. It's a part-time job. All right. I finished all of the lecture. So the practice we did today, I want you to submit at e-learning. At least you need to finish this one. This one. I will look at this one, and use the Johnson's rule. Practice on your own, and do not look at our textbook result. Solve it on your own. And the last one is staff scheduling. That's a kind of like an actual explanation, and let you know how to use this algorithm and how to work with this technique. And when you read the textbook, you understand all is conducted by using this way. And so we finished the entire book, and the last exam, exam 3, online exam, is only going to include the last chapters, So it is not the comprehensive exam, only cover the information and cover the information, course content, inventory control, and material requirements planning, and the short time schedule. So still open book. And the exam includes two portions. First one is multiple choice question. And the second one, it is problem solving. I do ask you to use Excel to complete the part 2. So for the, and then I give you two files, Word file and Excel file. Word file just kind of description, and Excel file I prepare the raw data already for you to use. You can work on that, okay, to help you to save some time. So the due time it is Sunday, December 15th. So, and you can start it at any time, but keep in mind 75 minutes it is the maximum. Once it is finished or the system counting already 75 minutes, it's going to be shut down. All right. And the second part is 30 minutes. So I will be available in my office